Hello, everyone, and thank you for attending the HashiCorp Zero Trust Security Roadshow. Our session today is about achieving security goals with HashiCorp Vault and AWS. AWS is a certified HashiCorp partner, and we are excited to co-present this session today. So my name is Aubrey Johnson, and I'm a product marketing manager supporting the secure product line here at HashiCorp, and I'll be co-presenting with Priya Magnani, Partner Solutions Architect at Amazon Web Services. So today our session is going to cover an overview of what Zero Trust Security is and how both HashiCorp and AWS are working together to enable organizations to leverage Zero Trust Security across their environments. So we'll have time for questions at the end. Please feel free to add them into the question box on your screen and we'll get to them at the end of the presentation. So my guess is that most of you may be familiar with HashiCorp, but for those of you who may be new to our community or just getting started with Vault, our focus here is really around addressing the challenges of modern infrastructure automation. So we look at a wide range of challenges. This includes how underlying infrastructure is provisioned and stood up, for example. So we solve this with Terraform and Packer. We also look at security challenges and how do we operate in a modern cloud environment with ephemeral infrastructure and poorly defined network boundaries, which is where our products Vault and Boundary come in. And we also address challenges around automating the network to support applications and the ephemeral environments with Console. And then lastly, HashiCorp addresses challenges around deploying and managing application lifecycles with Nomad and Waypoint. So just wanted to kind of give a quick overview of our platform before we kind of get started. So today we're first going to cover how HashiCorp views Zero Trust Security. And to set the stage, I really just wanted to highlight a few reasons why Zero Trust Security is so important and prevalent in today's environment. So US CEOs have placed cybersecurity as their #1 business concern, and there is an estimated about $6 trillion in losses that will occur in 2021. Additionally, over the last 10 years, 20 companies have experienced massive data breaches costing over $1 million, with 90% of those companies now transitioning to using Vault. So when we talk about security, we're really focusing on the challenges of being presented with digital transformation and sort of this movement from static infrastructure that was, historically easy to secure within, your four walls of a data center to now securing ephemeral and dynamic infrastructure with no defined perimeter and possibly multiple entry and exit points, increasing the risk of a potential breach. So this is where we have moved from kind of this perimeter model of securing four walls of a data center to now embracing a zero trust security model where we trust nothing and authenticate and authorize everything. This is essentially acknowledging the fact that it's increasingly difficult to secure an ephemeral and dynamic environment effectively. And now threats may not just be coming from, outside that static network or the four walls of your data center, but now may be coming from inside the network as well. So this changes the whole approach to security. And in the zero trust security model here at HashiCorp, we have moved toward identity-driven controls, which we have organized into 4 different and distinct pillars. So human authentication and authorization with SSO is going to be the first one. Next, we have human-to-machine authorization with Boundary. We have machine-to-machine access with Console, and then machine authentication and authorization with HashiCorp Vault, which is where we define, what that application or workload is allowed to do. So we're going to dive specifically into Vault in this session today. And when we're talking about Vault specifically, you can really start to picture it as a loop between the client, authentication, and the system, where the client identity is the basis of authentication and authorization. And the loop really starts with authenticating a client being, a human or an application workload, for example. And in the case of a human, they may log in with Okta or Active Directory credentials. And in the case of a machine, it may use Amazon IAM or a Kubernetes service, for example. So based on the client identity and authentication, Vault will then generate ephemeral credentials like tokens, certificates, or usernames and passwords for the systems that the client is allowed to access. And Vault really addresses three primary use cases. So the first one that we're going to focus on is secrets management. So this means that Vault centrally manages and enforces access to secrets, secrets being, tokens, certificates, usernames or passwords, anything that is considered essential and private. And then the systems based on these trusted sources of application and user identity. Vault is able to centrally store and manage these secrets instead of having them sprawled across various systems and teams. Secondly, we have data encryption. So Vault provides encryption as a service with centralized key management to help simplify encrypting that data in transit and at rest across hybrid infrastructure. And then lastly, we have advanced data protection, which provides an integrated way to protect data and workloads within your infrastructure with disk, virtual machine, and volume encryption, as well as providing protection in untrusted environments with one-way masking and two-way transformations. So in addition to these three use cases, secrets management, data encryption, and advanced data protection, Vault is also driven by three guiding principles. So the first one that we're going to look at today is identity brokering. Since now identity is sort of this fragmented concept, with identities existing in Amazon, for example, and perhaps in an on-premise Active Directory service, those two identities don't really mean anything to each other. So you can treat Vault as sort of a broker where you can log into Vault with your Active Directory credentials and then request credentials for other systems in your environment. Next, Vault is really here to support applications with the idea that Vault gets integrated into CI/CD systems within your environment. So integrated into applications, into monitoring, into remediation platforms that may be pre-existing in your environment, which of course requires us to have an API first approach. Lastly, we understand that in today's climate, there is a huge ecosystem of platforms and tools that users want to be able to integrate with. So today, Vault has over 70 official integrations. That number is constantly growing, which allows Vault to be able to extend and integrate into what may be pre-existing in your environment. So just to summarize, Vault in partnership with HashiCorp Console and HashiCorp Boundary use identity-driven controls to achieve zero trust security here at HashiCorp. Now I'd like to turn it over to Priya. She's going to cover AWS's view and how HashiCorp and AWS have partnered together to drive solutions to increase the security of your infrastructure.
Thank you, Aubrey. Now that we know what zero trust security means and also how you can achieve zero trust security with Vault, let's take a look at AWS's view on security. Security is job zero at AWS, and by which we mean it's even more important than the #1 priority. At AWS, security and compliance is a shared responsibility between AWS and the customer. Here in this chart, you can see the AWS shared responsibility model. There are two parts in the AWS shared responsibility model. AWS is responsible for security of the cloud. And what that means is AWS is responsible for protecting the infrastructure that runs all of the services that are offered in AWS cloud. The infrastructure is composed of, hardware, software, networking, and facilities that run the AWS cloud services. And customers, on the other hand, are responsible for security in the cloud. The customer's responsibility will be determined by the AWS cloud service that a customer selects, and this determines the amount of the configuration work that the customer must perform as a part of their security responsibilities. In conversational terms, you can think of the cloud as your office. So Amazon will take care of protecting the building, the parking, the mailboxes, but you are responsible for keeping the contents in your office safe. You're supposed to make sure that you keep your office door locked in order to make sure that everything is secure. And in terms of Amazon Web Services, for example, for a service like EC2 instances, customers are responsible for configuring the AWS provided firewall. They're responsible for any application or software utilities that are installed on the instances, or the management of the guest OS. In short, the customers are responsible for all of the security configuration and the management tasks. So from this, we understand that the security models of both HashiCorp and AWS are pretty much in alignment. So that was the AWS shared responsibility model. Now, what I want to do next is I want to walk you through some of the integrations between AWS services and HashiCorp Vault that will help you secure your infrastructure. And we will also look at those integrations from the lens of the shared responsibility model. I want to lay some groundwork here before we start talking about integrations. So let's start by talking about Vault unsealing. So when you first configure your Vault service, it is in a sealed state. And so Vault knows where and how to access the storage, but it doesn't know how to decrypt the data in that storage. So for that reason, Vault needs to be unsealed. Unsealing is the process of obtaining the plain text master key, which is needed to read the decryption key. The decryption key will then be used to decrypt the data and thus allow access to Vault. This master key is stored along with the Vault data, and it's encrypted using yet another mechanism called as the unseal key. So summarizing the process here again. So we have the unseal key, which is used to encrypt the master key. The master key is used to encrypt the decryption key, and this decryption key allows access to Vault data. So now we understand that if you want to access data in Vault, it needs to be unsealed. So let's take a look at what the manual unsealing process looks like. Vault is configured using the Summer secret algorithm. So what happens in this case is, instead of distributing the unseal key as a single key to an operator, Vault uses the Summer's secret sharing algorithm to split this key into shards. And a certain threshold of these shards are required to be able to reconstruct the unsealed key, which is used to decrypt the master key. So we understand that this process can be very challenging when you have many Vault clusters, because in that case, there will be multiple different key holders with multiple different keys. So this will require a lot of coordination, and this is not the best setup for an automated world. So for this reason, HashiCorp has a few integrations with AWS that can automate the unseal process. Let's take a look at those integrations now. The first one that we're going to go over is the auto unseal with AWS HSM. HSM is a cloud-based hardware security module that enables you to easily generate and use your own encryption keys on the AWS cloud. So in this approach, Vault protects its master key by transiting it through HSM for encryption rather than splitting it into key shares. In this integration, Vault puts its encrypted master key from the storage and transits this key that it pulled from the storage through HSM for decryption. And once this master key is decrypted, Vault uses the master key to decrypt the encryption key to resume with the Vault operations. So that is how you can do auto unseal with AWS HSM. And how this relates to the AWS shared responsibility model that we went over is, as a managed service, AWS HSM is protected by the AWS Global Network Security Procedures. So AWS will take care of the infrastructure security for you. It will make sure that the data is replicated across multiple availability zones, and hence it's highly available. It will also make sure that HSM meets the compliance requirements. Customer, on the other hand, is responsible for making sure that they control access to HSM by configuring the IAM permissions correctly, by making sure that only the right users and groups have access to it. And also, they can restrict the actions that are allowed on that key. Customers can also make sure they use MFA with each of these accounts, or if they need to use a FIPS endpoint, if they want to use the FIPS validated cryptographic modules. So that was the HSM integration. Another method for Vault auto unsealing is using AWS KMS, and KMS here stands for Key Management Service. When you're configuring Vault, Vault gives you the option to opt in for automatic unsealing using AWS KMS. So how this works is, in this case, you're no longer giving the key to humans, and you're using AWS KMS to store the master key there. As you can see in the diagram here, the KMS key protects the master key, which protects the encryption key. So if you have the need for a more ephemeral vault setup and you want to be able to restart your vault setup at say 3 a.m. in the morning and unseal it automatically without having to involve say PagerDuty or Git operators, auto unseal is the way to go. Also, how KMS relates to the shared responsibility model that we went over is AWS makes sure that the key material is encrypted, it's stored in durable persistent storage. AWS will also make sure that it meets the security and the compliance requirements of programs such as SOC, PCI, FedRAMP, HIPAA, and others. And customers are responsible for making sure that they configure the IAM permissions correctly. And they can also configure the key policies to configure access to the key. Also, AWS provides certain tools for monitoring the key, like Cloud Trail logs or CloudWatch logs, CloudWatch events. So customers are responsible for making sure that all of it is configured properly. Moving on, let's talk about another method here. It's called Key Management Secrets Engine with AWS KMS. It's a new feature and it's in beta currently. So the use case for this method is sometimes enterprises might need to maintain and manage the key and its lifecycle themselves outside of the cloud provider. So in order to comply with these regulatory requirements, Key Management Secrets Engine can be used. This method allows organizations to maintain centralized control of their keys in Vault while still taking advantages of the cryptographic capabilities that are native to KMS providers. And how this works is the secrets engine generates and owns original copies of the key material. And when an operator decides to distribute and manage the lifecycle of a key in one of the supported key KMS providers, a copy of this key material is created and that copy is distributed. So you can see that this method also provides additional durability and also disaster recovery. In version 1.7, the Key Management Secrets Engine supports AWS KMS in beta. Also, we know what the shared responsibility model for KMS looks like, right? So these were 3 integrations that I wanted to talk to you about. And with this, I will pass it back to Aubrey.
Thanks, Priya. So next, I wanted to highlight one of the newest additions to the suite of HashiCorp products, which is HCP Vault. We launched this in April of 2021, and it's an easy way to deploy HashiCorp Vault in the cloud. We'll get into some details about that next. So HCP Vault gives you the power and security of HashiCorp Vault without the complexity. Hi, everyone. Thanks for joining today. I think we got cut off a little bit early, but happy to jump into some questions. If there's any in the Q&A, please feel free to add them to the box on the side of your screen, and we can go ahead and get into those. In the meantime, while we're waiting for some questions to come through, I'm happy to highlight some information on HCP Vault. So we launched HCP Vault here at HashiCorp at the beginning of April. And HashiCorp Vault is our cloud managed service for Vault. It has all the capabilities that Vault has. It's just going to be in a cloud managed version that's managed by HashiCorp. So you can actually access and download and use that now. It's available on our website, and you can deploy a variety of different cluster sizes to test out in your environment. So we have a few questions that look like are coming through now. So we have a question around what does Vault compete with? So Justin and I can kind of take that. Justin's another one of our team members on the Vault team. So Vault essentially competes, or it's kind of in its own world. So there's not necessarily a direct competitor. We are, competing with various different tools that may cover secrets management and security. Justin, I don't know if there's anything specific you'd like to add to that.
Yeah, I'll dive in. I think maybe take a step back with and look at the workflow or use case that Vault actually, implements. So when we say, hey, Vault limits the secrets fall throughout your infrastructure, what does that actually mean? Well, it means, hey, I might have usernames and passwords embedded in, source code. Say, for example, hey, I have a web app, needs to connect to a database. Oh, there's like, a connection string in there, and it has a username and password. Oftentimes, that's just hard-coded in there, right? Or, hey, I have a username and password sitting in a config file. Or, hey, maybe my web app or application's connecting to an external API. So I have API keys in there. Especially when you're talking about AWS, you're talking about highly, privileged API keys. You don't want them just sitting around. You don't want to accidentally upload them to GitHub or something like that. So when you look at, obviously there's other tools out there too. So when you look at like, hey, what's the compete landscape? You're looking at, we're competing with like people just putting credentials right in text files all the way up to, other password managers out there. So I think oftentimes the folks that we're chatting with though is, they're just looking at, hey, how can I centralize my secrets so that I can get like a, a correct, sort of audited and logged workflow around secrets. So, yeah, that's all I'll say there.
Awesome, thank you. Next question that we got through is asking if we could elaborate a little bit on the database credentials rotation for AWS RDS. Can Vault federate application access to the RDS?
Sure, yeah, I'll take that one too. So there's probably two different workflows that we could chat about here. Maybe I'll start with the sort of simplest one, and then we'll move on to a more sort of the expanded use case. The first one is, Vault has a capability. When I just chatted about, hey, we can take static secrets out of, source code, text files, all that stuff, and put it into Vault, and it's, centralized, audited, logged, all that stuff. But there's a more advanced use case called dynamic credentials where, hey, say for example, I want access to, an AWS, API key or something like that. Vault can actually integrate with AWS to say, hey, generate me a short-lived credential based on some policy. Maybe I need access to spin up EC2 instances or access to S3 bucket for a backup job or something like that. You can ask Vault, hey, generate me a short-lived credential that has this associated policy, and I'll go out and do that. A Vault will actually revoke it after the time period. So say, hey, I have a brief 5-minute window where I want to go do this particular job. You can create a dynamic credential to do that. So we take that same sort of primitive of dynamic credentials and we expand it over both static and dynamic credentials, and we can expand it over into our AWS RDS. So, you can tell Vault, hey, go generate me a database user based on the policy that I've created. Vault will actually integrate with the AWS RDS, via SQL. It'll log into the database and generate that credential for you. So we can do static credentials. We can also rotate credentials. So say, for example, hey, for compliance reasons or something like that, I need to rotate this particular application's credential once a month. Vault can be set up to do that. And then we support the sort of more advanced use case of dynamic credentials. Well, where, hey, for example, I have a web app, it's spun up. It can ask Vault, hey, go generate me a credential for this database. Vault will go log into the database and then provide that credential back to the application. The cool thing about this is, each application or set of applications can have their own, there can be a one-to-one relationship between the application and the credential in the database. You can also do things like, when you configure that sort of AWS RDS, plugin or integration there, you can say, use this particular username schema or something like that. So if you're on the RDS side, you can list the users and say, it can be logical. You can map it back to, hey, what credentials did Vault actually create? I know I talked about a lot of stuff there, so I think the main takeaway is, hey, you can do static credential. You can do, monthly rotations or something like that. And you can also do more advanced use cases of dynamic credentials.
Awesome. Thanks, Justin. So next question we'll dive into is, in a specific example, if KMS is down and the keys are in KMS, is there a way that we can unseal Vault in this case?
I can take that. So KMS as a service, because it's so important, it's designed to be highly available. And what that means is the encrypted data that is stored in KMS is replicated across multiple AWS regions. So multiple across AWS availability zones. So the chances of multiple availability zones going down at the same time is really negligible. And also it's designed for 99 point, I think it's 99's durability. So you can consider that KMS is a highly secure service to work with.
I'll also maybe add on to that of why would you even use the AWS KMS in the first place? There's a super important reason, right? So if you don't have that auto unseal functionality enabled, if Vault for some reason encounters an operational issue and it's 2 a.m. in the morning, you're going to be paged saying, hey, Vault is down. It's in the critical path of all my applications. And the sort of core functionality there is that it allows Vault to auto unseal or heal itself. So we always recommend that people use auto unseal when possible, either on-prem if they have a HSM or obviously in AWS with the HSM.
Cool, thank you. So now someone wants to dig into basically what the advantages or differences are between HCP Vault versus AWS Secrets Manager. Does a hybrid cloud or on-prem architecture orient the choice of secrets management solution?
I can chat about that a bit. So maybe I'll take a step back and we'll sort of layer it up. So you have Vault. You've centralized all your secrets. You have an audited and logged workflow now. So this the use cases sort of run a spectrum of like small startups or single person startups to small, medium startups, all the way to like mega corporations, right? So it's tough to give an answer that crosses all of them, but I'll maybe just explain it. So, you centralize all your secrets. You have a bunch of different teams that have a single workflow now. So say a team comes in and they say, hey, I want to access these particular secrets. You might have some internal procedures that say, here's how you access Vault. Here's the secrets that you can access, all that type of stuff. So that works great if you're like on-prem, and then, hey, I want to go to the cloud. A lot of folks want to use the same workflow. So that's sort of like, one of the main features of why you would, use Vault in multiple environments. Vault also, is sort of like a Swiss Army knife. There's a lot of different functionality in there in terms of, on the enterprise feature side of, say, tokenization. Hey, I have, I'm processing, credit card numbers, passport numbers, membership numbers. If you even look at a simple, store application, for example, they have a lot of different secrets in there. They're going to have a lot of different API keys. They're going to be processing potentially PII data, credit card numbers and stuff like that. So Vault's sort of like a Swiss Army knife that has a bunch of different, functionality and integrations, as well as we call them, secrets engines. They're basically plugins that can integrate with things like RDS. So I think it's more like around workflow and what your use cases would be that would probably drive the decision. But if you're tightly in AWS and you're already using secrets there, or you have like you don't have the need for Vault's the extended functionality, then I'd totally use AWS Secret Manager, like just because it's obviously much simpler. You don't have to maintain a third product of Vault.
Perfect. Thanks, Justin. So this next one's around this use case is we use SSM via AWS console to get our EC2 instances. How can we use Vault's SSH engine to track specific users when we have multiple users logging into our EC2 nodes?
That's a good question. Right now, I don't know the answer off the top of my head because I'm not like super familiar with SSM on AWS. So I will say that if you Google SSH HashiCorp Vault, there's a great talk that comes up where they walk through the particular workflow. There's I think it's about a 45-minute YouTube video on there that walks you through like end to end how it all works. So I'd probably direct you to just Google it because I don't know the answer. Thanks.
Okay, thanks. Let's see. So this is about dynamic credentials. It sounds like dynamic credentials only really reduce the window of access, but as long as one can make many such requests each time, does it really solve anything except for being another layer to pass through?
I think it does. Yeah, obviously, if you can reduce the window that an attacker has the ability to, utilize a credential. Say, for example, hey, I'm using a dynamic credential and I accidentally upload it somewhere. The window's greatly reduced. You can also trace it back to, hey, who generated this credential? Like you can go and actually look through the audit log to figure out, hey, who generated this credential, so you can, find where it came from. Let's step back and say, hey, I'm not using any of this. I'm just using hard-coded credentials. They're in a config file. They get uploaded to GitHub or something like that. Someone logs in and starts exploiting my environment. How do you trace where that came from? Right? So I think it's pros and cons you have to sort of look at and weigh. Even if someone does exploit a dynamic credential, yeah, they're still in your environment, but they have a brief window where they can do something about it. You have the traceability. On the other hand, hey, they leverage a credential that has no audit trail and we don't know where it came from. That's probably a much worse place to be in. So I think it's all pros and cons.
Awesome, thank you. Let's see, we just had another question come in. So apart from centralizing secrets and dynamic credentials, you see what makes Vault differentiated because AWS KMS and parameter store also uses identity-based access.
I think we already covered this. I'd probably just say, Aubrey, I know in your talk there you mentioned, hey, we have, I don't know what the exact number is, but it's lots of different, plugins with Vault.
Mm-hmm.
So, hey, say for example, I want to do PKI infrastructure. Hey, I want to generate, SSH keys. Hey, I want Vault to go out and generate dynamic credentials for a particular cloud provider. There's a ton of different use cases. I'd say the way I'd probably, maybe I'll take a step back and just talk about sort of the thinking that goes into when you're, choosing a different, say piece of infrastructure software. I came from, a career of being like a sysadmin for a long time. And, a problem comes in and you're thinking, okay, how are we going to solve this? So typical sort of workflow is, hey, I'm going to go look out, I'm going to go Google a bunch of different tools that, solve my workflow or problems that I have. And, you might create some sort of little feature matrix that says, hey, I have these particular 5 problems that I need to solve. And here's the sort of how these different solutions map into it. It's tough for me to say, hey, what your workflow or, those use cases are. I just say that, Vault covers a lot of those use cases and you sort of have to map it into, how you're going to use it. I know that's probably not the best answer, but it's like, I think it's probably practical to how you're actually going to go about solving that problem. So I'd probably focus on the workflow of like how to actually go through the process of solving that problem versus just giving you a blanket answer.
Cool. Thank you, Justin. So it looks like we got through all of our questions, but just wanted to say thank you again for everyone who attended today. We have a couple resources that you can access after this session. So if you're interested in trying HCP Vault, you can set up an account on our website. We also have a very extensive Learn console and module where we have lots of different content where you can go and kind of learn more specifics on Vault and HCP Vault. And then additionally, if you're interested and you have AWS credits, you can use those and apply those towards HCP Vault via the AWS Marketplace. And thank you again for attending. Enjoy the rest of the Zero Trust Roadshow.
Thanks, everyone.